Hello everyone. Now we will be solving a sample problem related to Kirchhoff's rules. We have here an electric circuit that is sketched. It's a simple circuit somehow, not very complex, with two cells, 1.5 volts and 9 volts here, and two resistors, 100 ohm and 200 ohms. We have here current I1. Here is a junction. I can name it, let me say A. And here I have another junction, B. I1 divides to I2 and I3. Then they gather again here. Here I3 will come back and I2. They will gather and make I1 again. This is I1. This is I1, yeah, and this is I2. Please make sure that everything is clear before we start. Things that we need to know before we solve the problem. First of all, you need to remember Ohm's law. Usually we just sketch this triangle on the side, VIR. We will be mainly using V equals IR, okay? Something else we need to know, the junction rule for sure, junction rule. Kirchhoff's first rule, which is the junction rule, which says that currents in equals currents out. So on A, let's say, currents in is I1, which is equal to I2 plus I3. We need to find the values of each one of them separately. So we will go to the loop rule. Loop rule here says that delta V across each loop is equal to 0. Here I have two loops that I can study, and this loop, for example, and this loop. You can take the outer one, but if you take just the two inner ones, it will be enough. And usually, how do we start? Okay, this is the first loop. Let's say I will select this direction, and I will name the loop here A, and here the same direction, and I will say this is loop B. We will start with loop A first. Loop A. So across loop A, as we said, delta V equals 0. One tip that all the time to see is the potential positive or negative, all the time from any battery or any cell, make an arrow going out from the negative to the positive. Here the same thing, from the negative to the positive. If we go with the arrow here, then this potential will be positive. As you can see here, we chose this direction for our loop. So 1.5 is just with our direction, so it will be positive. 1.5. Now the opposite happens to the current. Once you go around the loop, here you have I2 entering in R here, in R, which is the 100 ohm. So I2 is with the loop. As you can see, I2 is going down, the loop is also here going down, so it is negative. Negative means potential is dropping here. Negative V across this resistor. V, as we said, it's IR, so negative I2 times 100. IR, girls. IR means V. This will be equal to 0. I have nothing else in this loop. Only I have potential rise from the battery, potential drop across this resistor. So again, I'd like to write the rules that I did here. This arrow all the time going from negative to positive in all batteries of your cell, and you will say that delta V will be positive for the battery if it's with loop, and IR, which is delta V for the resistor, will be positive, this is one across the resistor, if you are against loop. Okay, now let us apply the same idea for loop B. I'll use green. Loop B. Now I chose the direction to be this way. By the way, the direction here that you choose for the loop is arbitrary. You can choose the opposite way and the signs will flip, so no problem in that. For loop B, okay, as you can see, for the battery we are against the loop, so against the loop with the battery means negative, -9. But for the current that is going through this resistor, the 200 ohm, it's just I3 going down this way. So for the current we are with the loop, means again negative, I3 times 200. Don't forget here that this 100 ohm is also considered in loop B. So what is the current actually in the 100? It's this I2. As you can see, this current, if you follow the loop, this current is opposite to the loop. It's going down and the loop is going up. So I2 will be positive, I2 times 100. This will give me the 0. Now here we can just do some algebra. Going back to loop A, I will say 1.5 is equal to 100 I2, taking it to the other side. So I2 will be equal to 0.015 amps. Now, substituting this here, -9 minus I3 times 200 plus I2 multiplied by 0, okay, instead of I2 I'll be substituting 0.015 multiplied by 100. Solving this equation, you will find I3. I3 will be negative 0.0375 amps. Girls, when we get a negative sign, this means the direction that we chose for the current is not the correct one. So I3 is not going this way, is actually going the opposite way. When the circuit is complex with two cells, we cannot just predict it normally, but we can assume it. And if we got a negative sign for any current, this means the correct direction is the opposite one. So let me find now I1. To find I1, I'll go back to the junction rule. Okay, so the loop rule helped me to find I2 and I3. Go back to junction rule. I know that I1 is equal to I2, which is 0.015, negative 0.0375, and this will give me also a negative number, negative 0.0225 amps. Also, I1 is assumed here the opposite direction. It's the wrong direction. We say that here it's wrong direction. But anyway, it doesn't affect the magnitude of it. I hope that it's clear. I know it's a new idea. Just if you know these, everything will be easy. All the time assume the arrow here for the battery from negative to positive, and check the direction of the current inside the resistor. For the battery, if we are with the loop, it's positive. If we are against the loop, it's negative. The opposite goes for the current. If we are with the loop, it is negative, and if we are against the loop, we will get the positive sign. I'll post more examples and the worksheet, and we will be practicing a lot on Kirchhoff's rules until you are all experts in it. If you have any question, please feel free to ask.